From Vandenberg Air Force Base in Central California, you're watching live launch coverage of NASA's interior exploration using seismic investigations, geodesy, and heat transport, or InSight spacecraft, to study the interior of Mars. Hi, I'm Stephanie Martin, and thanks for joining us. NASA's InSight mission is the 20th mission to Mars. Previous missions have taught us a lot about the planet's surface, atmosphere, and ionosphere. InSight, however, will teach us about what goes on a mile or even 2,000 miles below the surface. This will help us understand how rocky planets like Mars and Earth were formed and why the two planets are so different 4.5 billion years later. Today, we have team coverage from NASA's Joshua Finch, Troy McClendon, Blair Allen, Chris Gersh, and Franklin Fitzgerald, who are with launch teams across the Air Force Base. InSight is flying on United Launch Alliance's Atlas V 401 configuration and has a 2-hour launch window starting at 4:05 this morning Pacific Time or 7:05 Eastern Time. This means that launch teams have 2 hours to lift off from Space Launch Complex 3 at Vandenberg Air Force Base. InSight is set to land on November 26th in the Elysium Planitia region of Mars, which is about 373 miles from the Gale crater, where NASA's Curiosity rover touched down in August 2012. After InSight lands, it will spend 728 days, or a little over a Martian year, studying the planet's interior. InSight will be the red planet's first thorough checkup since it formed 4.5 billion years ago. InSight will take the vital signs of Mars, specifically its pulse, its temperature, and its reflexes. After the spacecraft's roughly 6-month journey to Mars, it will begin its landing phase. InSight enters the Martian atmosphere traveling at 13,200 miles per hour and deploys its parachute and ultimately slows down to about 5 miles per hour for touchdown. 1 minute later, InSight will begin its surface operations, checking out the lander's health indicators and then deploying its solar arrays. It will take about 10 weeks to place all the instruments on the ground. About 7 weeks later, it will sink its self-hammering heat probe about 10 to 16 feet into the Martian soil. There are also 2 briefcase-sized CubeSats known as Mars Cube 1, or MARCO, hitching a ride on today's mission as a part of a NASA technology demonstration mission. MARCO A and MARCO B will deploy from the second stage of the Atlas V about a minute after InSight separates and will then fly toward Mars. We are now about 30 minutes away from today's launch. Let's check in with NASA's Joshua Finch in the Mission Director Center for a status on today's launch and a weather update. Josh?
Thank you very much, Stephanie. I'm in the Mission Director Center at Vandenberg Air Force Base. Inside of the Atlas Launch Control at the Remote Launch Control Center, NASA Launch Manager Tim Dunn and United Launch Alliance Launch Director Lou Mangieri are working through their steps to count down toward liftoff. The entire launch team began arriving on console a few hours ago and are working through the necessary steps. We are expecting to receive a weather report from the U.S. Air Force 30th Space Wing located at Vandenberg in just about 30 seconds, and we'll bring that to you. The weather team looks into a whole insight of weather-related details such as wind speed, cloud coverage, potential for lightning in the surrounding area, and even solar weather, which launch teams need to know before committing to launch. Tonight's launch is a collaborative effort between NASA, United Launch Alliance, and the United States Air Force. And that briefing's in about 5 seconds, and we'll listen in.
T-minus 15 minutes.
Attention on the weather conference net. Stand by for the weather briefing. All stations acknowledge LO,
Hello?
RC,
RC.
LD,
LD.
NLM,
NLM.
AFLD, OD, Click, repolling AFLD. Nothing heard. LWO, provide latest L0 status for safety and launch agency constraints with probabilities of violation.
This is the LWO. For range safety, weather is green with a T0 POV of 0% with no areas of concern. For launch agency, weather is green with a T0 POV of 0% with no areas of concern. The overall POV is 0% with no areas of concern. The POV for the scrub day T0 is 80% with an area of concern for range safety launch visibility. This concludes my brief.
LWO indicates clear to proceed. All stations report questions or acknowledge. LWO,
LWO.
RC,
RC.
LD,
LD.
NLM,
NLM.
AFLD,
AFLD.
OD, OD, Slick.
Look.
Weather conference net, clear.
And as you just heard, that was the launch weather officer from the 30th Space Wing, Lieutenant Williams, giving launch teams their final weather briefing before tonight's launch. There is a 0% probability of violation for tonight's launch. The only concerns initially were launch visibility. As you can see on your screen when showing the rocket, there is a lot of fog in the area, an area of marine fog sort of settling around the pad, although that's not a constraint for launch tonight. So good news for the launch teams. As I mentioned, this is a collaborative effort between NASA, United Launch Alliance, and the U.S. Air Force. The Air Force not only briefs the launch teams of weather which could impact launch, but they also keep the launch team aware of other considerations on the Western Range, including telemetry, public safety, and update teams about COLAs. COLAs is in reference to collision avoidance analysis done by the U.S. Air Force team. One of the considerations is objects in space, for example, other satellites around Earth that could be in the flight path of Atlas. Within this 2-hour launch window, there could have been cutouts where launch teams would not have been able to lift off. However, this analysis is complete, and we have no cutouts due to COLAs during our launch window tonight. Right now, you're looking at a live view of the launch pad, Space Launch Complex 3E, and the Atlas V in its 401 configuration. The Atlas V is a 2-staged rocket, and the number 401 indicates a couple of key features about the rocket that will power NASA's InSight on its journey to Mars. The 4 indicates a 4-meter fairing. Inside that protective cover at the top of the rocket is where the spacecraft destined to study the interior of Mars is tucked away. The 0 indicates the number of solid rocket motors. In this case, there are no solid rocket boosters for this mission, and the 1 indicates a single-engine Centaur upper stage, thus the 401. Space Launch Complex 3 is United Launch Alliance's West Coast launch pad for the Atlas V. At Space Launch Complex 3, launch vehicle integration, testing, spacecraft mate, and integration operations happen in a mobile service tower. Just beyond midnight, the mobile service tower was rolled back to its park position approximately 250 feet southeast of the rocket. This will be the 15th Atlas V launch from Space Launch Complex 3. Right now, we are at T-minus 11 minutes, 27 seconds. All fueling operations are underway. The Atlas V booster is being filled with liquid oxygen and RP-1, a rocket-grade kerosene. That fuel will power the first stage's RD-180 engine, producing more than 860,000 pounds of thrust at liftoff. The Centaur upper stage is also being filled with liquid oxygen and liquid hydrogen. The Centaur upper stage is powered by a single Aerojet Rocketdyne RL-10C engine. Things are progressing toward liftoff for 4:05 a.m. Pacific. We do have a 2-hour window for tonight's launch attempt, should launch attempts for the teams need more time. Liftoff times are available in 5-minute increments throughout the window. So lots going on, and while we follow the action here from Atlas Launch Control, we'll go back to you, Stephanie.
Thanks, Josh. Exploring Mars helps us understand how our solar system was created and how planets evolve. Joining us now is NASA's Chris Gersh. He's standing by with NASA Chief Scientist Jim Green, who can tell us more about why we study Mars. Chris?
Thanks, Stephanie. Jim, we're here at Vandenberg Air Force Base on the West Coast, and the cool thing is we're talking about a Mars mission. Tell me about that.
An interplanetary mission, something that's going to leave the gravity of the Earth. Now, what happens is Vandenberg's great for putting spacecraft into polar orbit. We fire straight south, and that way it goes over the ocean, goes under the South Pole, comes up on the other side of the Earth, and then takes this mean left and heads on out to Mars. How cool is that?
That is cool. You know, and you've been studying Mars for a long time.
Yeah.
You used to be the Mars program manager.
Yes, I did.
And now we have InSight, and for the first time, we're going to be looking at the vital signs underneath the planet. Tell me a little bit more about that.
Well, indeed, it has some spectacular instruments, you know, like the SEIS set of seismic measurements. It's already late for me. You plop it down on the surface, and you measure some of the most sensitive Mars quakes around. Now we know Mars is quaking. not only do we see avalanches from orbit, like with MRO, but also craters. New craters come up, and when Mars gets hammered like that, it's got to be quaking. So seismic waves will be seen, that's for sure. And then we'll tease out what the structure, the interior structure of Mars is. How big is its core? Whether that core is liquid, or at least an outer layer. How big is the mantle and the crust?
Now, how do you take all that data? We're looking at the vital signs. We have MAVEN, who's studying the solar wind hitting the atmosphere. We have the Curiosity on the planet. We have the satellites orbiting Mars. All that data that we have, it seems like we know a lot about Mars.
We do, and much of that we have to connect between these missions. For instance, there's a magnetometer, an instrument that measures magnetic fields on InSight. Now, Mars doesn't have a magnetic field.
Right.
However, the solar wind, when it hits the planet, hits the ionosphere, causes this huge current to occur. It can be measured on the surface by that magnetometer. And so when really hefty solar wind hits Mars, we're going to see that. And that's going to be really fantastic. That current will be connected with the MAVEN mission, so we'll understand better the stripping mechanism that's going on.
Now, I understand on this particular mission we have something special, and I
Yes.
think you have something in your pocket.
We do.
Let's share that with our
Here
viewers.
Here it is. It's a little chip. Let's see. I'll go this way.
Yep. Yep.
And this little chip has got 2.4 million names on it.
Wow.
We had a website. We opened the opportunity up for people to indeed submit their name. My name's on this, okay? And so you got to give me a little time to run out and weld it to the deck,
I tell you, on that note, thank you so much, Jim. We're looking forward to the launch in less than a half hour. And I'm sure you got a pretty good spot to see the launch.
Absolutely. And, of course, as we say, go InSight.
Stephanie, Jim has a ton of energy. He's been up over 24 hours. Let's take it back to you.
Thanks so much. The journey to today's launch has been a long time in the making. Here's a highlight reel of all of the work that the teams here at Vandenberg Air Force Base have done to prepare for today's launch. We are now about 20 minutes away from today's launch. Let's go back to NASA's Joshua Finch in the Mission Director Center for an update. Josh?
Thank you, Stephanie. Things still progress toward a liftoff at 4:05 a.m. Pacific time. Again, I'm in the Mission Director Center on Vandenberg Air Force Base, listening in to the launch teams as they move through the necessary steps to bring us to liftoff. We're getting about just a minute away from a hold in the T-minus count. We're about 50 seconds away from that hold in the count. Although the T-clock stops or pauses, launch teams continue to work diligently toward liftoff. The T-clock is the official countdown clock and is stopped at the T-minus 4 mark in the count and holds for 15 minutes. At the end of the hold, the T-minus and L-minus counts will be synced and only 4 minutes will remain until launch. We have about 30 seconds left till we hit that pause in the count.
LC, this is flight control.
Go flight control.
Yeah, I have a series of yellow alarms for RCU switch miscompares. We think we understand what the cause of it was. Sounds like there was a switch on when they attempted to switch to secondary decom.
And we have now entered the hold in the T-minus count. The L clock still continues, so at the launch minus clock, we're at 18 minutes, 50 seconds until liftoff. This is the first interplanetary launch for NASA from the West Coast, but NASA is no stranger to the Atlas V rocket, which you see on your screen. In fact, this launch of InSight on the Atlas V will be the 17th time NASA has flown a spacecraft on this rocket. All previous NASA interplanetary missions have launched from Florida's Atlantic coast at either Cape Canaveral Air Force Station or the adjacent NASA's Kennedy Space Center. Launching toward the east adds the momentum of Earth's eastward rotation to the launch vehicle's own thrust. For InSight, the Atlas 401 offers enough performance to enable launching a mission to Mars southward from Vandenberg. The propulsion for pushing InSight from Earth to Mars comes from the launch vehicle rather than the spacecraft itself. At liftoff, NASA's InSight spacecraft will begin its 6-month journey. The Atlas, in just over a minute, is traveling faster than the speed of sound after liftoff. At 2.5 minutes into flight, the rocket weighs less than half of its original weight at liftoff, and the first stage engine burns all of its propellant or fuel. By about 4.5 minutes after the rocket's first stage has jettisoned, the second stage engine ignites for the first of 2 burns, and the protective payload fairing at the top of the rocket will have been jettisoned. At 1.5 minutes after liftoff, the InSight spacecraft and 2 CubeSats called Marco, hitching a ride to Mars, will have separated the Centaur's second stage. Here's a detailed look at the United Launch Alliance Atlas V mission profile.
5, 4, 3, 2. We have ignition of the RD-180 main engine. 1. Liftoff of the United Launch Alliance Atlas V rocket.
The Atlas V RD-180 main engine ignites and generates more than 860,000 pounds of thrust to lift the rocket away from the pad. Shortly after liftoff, Atlas begins a pitchover to attain the proper flight path while minimizing the pressure the vehicle experiences during flight. The Atlas V reaches Mach 1 at the speed of sound at 1 minute 17 seconds. At 4 minutes 4 seconds, propellant levels deplete and the main engine shuts down. 6 seconds later, the Atlas Centaur separation system activates to release the booster stage. The vehicle now weighs a little more than 7% of what it did at liftoff. At 4 minutes 20 seconds, the first Centaur main engine burn begins, sending the Centaur into a circular orbit. Approaching payload fairing jettison, the Centaur is burning propellant at a rate of 51 pounds per second, traveling at more than 10,000 miles per hour, and located 79 miles in altitude and 252 miles downrange. During ascent, InSight is protected inside a 4-meter diameter payload fairing. At approximately 4 minutes 28 seconds, the payload fairing is jettisoned. At 13 minutes 16 seconds, cutoff of the Centaur main engine, or MECO-1, occurs. The mission now enters an hour-long coast phase. At nearly 1 hour and 15 minutes, the Centaur main engine is restarted for the second and final burn, placing Centaur on its path to spacecraft separation. Approximately 4 minutes and 49 seconds later, the final cutoff of the Centaur main engine occurs. At 1 hour, 28 minutes, and 40 seconds, Centaur releases NASA's InSight spacecraft on its journey to Mars. Deploying from dispensers mounted on the aft bulkhead carrier on Centaur, the Mars Cube 1, or Marco CubeSats, will provide real-time communication relay covering the entry, descent, and landing of InSight on Mars. Marco A separates 1 hour, 29 minutes into flight, followed 48 seconds later by the separation of Marco B.
From the Mission Director Center, we're about T-minus 4 minutes in holding. We have about 14 minutes, 40 seconds left before a liftoff. With that, we'll go back to Stephanie Martin. Stephanie?
Hi, I'm Stephanie Martin. For those of you just joining us on social media, we'd like to welcome you to launch coverage of InSight, which will give Mars its first thorough checkup since it formed 4.5 billion years ago. InSight will take the vital signs of Mars, including its pulse, its temperature, and its reflexes. InSight is flying on United Launch Alliance's Atlas V 401 configuration and has a 2-hour launch window starting at 4:05 this morning Pacific Time or 7:05 Eastern Time. This means that the launch team has 2 hours to lift off from Space Launch Complex 3 at Vandenberg Air Force Base. InSight is set to land on November 26th in the Elysium Planitia region of Mars, which is about 373 miles from the Gale crater, where NASA's Curiosity rover landed in August 2012. After InSight lands, it will spend 728 Earth days, or a little over a Martian year, studying the planet's interior. After the spacecraft's roughly 6-month journey to Mars, it will begin its landing phase. InSight will be the red planet's first thorough checkup since it formed 4.5 billion years ago. InSight will take the vital signs of Mars, its pulse, its temperature, and its reflexes. After InSight enters the Martian atmosphere, traveling 13,200 miles per hour, it deploys its parachute and ultimately slows down to 5 miles per hour for touchdown. 1 minute later, InSight will begin surface operations, checking out the lander's health indicators, then deploying its 2 solar arrays. It will take about 10 weeks to place all the instruments onto the ground, and about 7 weeks later, the self-hammering heat probe will reach 10 to 16 feet into the Martian soil. There are about 2 briefcase-sized CubeSats known as Mars Cube 1 or MARCO hitching a ride on today's mission. Now with that, let's go back to NASA's Joshua Finch in the Mission Directors Center.
A27. Yeah.
I take that back. NASA's new administrator, Jim Bridenstine, shares his thoughts on NASA's InSight mission, the future missions for human exploration plans, and what NASA's impact is on the world.
So what Mars InSight lander is going to allow us to do is really map the inside of Mars. This is an important mission, not just for the United States, but an important mission for the world, so we can better understand why planets change and ultimately understand even more about our own planet. I think the one thing that really excites everybody is a question that we ask ourselves over and over again, which is, are we alone in the universe? Is there potential for life on a planet that's not our own? And one of the things that we want to do with Mars 2020, which is going to launch during the next window we have to go to Mars, is understand if there was a potential, or maybe even Mars might have at one time hosted life. If we want to get as much science as we can, as fast as we can, we need to get really good at using robots. We're going to have robotic missions to the moon before we have humans go to the moon, so that we can get the most out of our human science missions. And that's true on Mars as well. This president and vice president are very committed to getting America back to the surface of the moon as fast as possible. Earth, because we live here. And it's the only planet we know that can host life, so we better take care of it. When I was 5 years old, they made us draw what we wanted to be when we grew up, and I drew a picture of an airplane. I had a picture of myself there wearing a hat that I thought airline pilots wore. As a pilot in the Navy, I became very dependent on space-related capability. And a lot of the technologies that come from NASA have multiple uses and have transformed the way we live our lives. So people say, why are you interested in space? I think the question is, why wouldn't you be interested in space? It's critical to our everyday lives. So this is a critical mission for our country. It's a critical mission for the world. These are some of the brightest minds that our country has. We've got great international partners, and our nation is grateful, and in fact the world is grateful for their service.
It is great to hear from our new NASA administrator. Now remember, you can follow him on Twitter using @JimBridenstine. We're now a little more than 9 minutes away from today's launch. Let's go to NASA's Joshua Finch in the Mission Director Center for the final countdown of today's launch. Josh?
Thank you very much, Stephanie. And I'm actually being joined by Alyssa Macbeth from United Launch Alliance. Alyssa's going to give us a little more insight in today's mission. Alyssa, can you tell me about your role at ULA and what it's like to work for InSight?
Yeah, thanks for having me here. So I work at the launch site. I'm a systems engineer for launch operations, mainly in the avionics department. So that covers everything from batteries to harnessing to the flight boxes that takes the rocket to where it needs to go in outer space. My personal role, I'm also involved with ordnance, so installing all the pyrotechnics that separate the stages, separate the spacecraft from the vehicle on orbit, those kinds of things. So that's mainly what I'm involved with. And on InSight, I was able to, it was my first West Coast launch, and on InSight, I was able to come out here for the past couple of weeks and do just that, install batteries, install some ordnance, and do some final connections.
So you're often on console for your ULA launches. Can you tell us what it's like to be on console?
Absolutely, yeah. So on console it's an experience. It's very exciting. The adrenaline in the room, you can feel the energy. There's a lot of system testing happening just to prepare the rocket for launch and verify that everything is in configuration and nominal. We fuel the rocket at that point, T-minus 2 hours and counting. And then it's really just some final checks to verify that everything is good. We've got a team of people at the launch site sitting on console, as well as our certified responsible engineers in Denver, who are also having a second set of eyes on the systems as well.
And so can you tell me what's happened up to this point in the countdown and what we can expect before launch?
Yeah, so we're getting up to the terminal count now. So terminal count is T-minus 4 minutes and counting. So up to this point, the rocket is fully fueled. We're doing some final system checks. All of the testing that I talked about earlier is completed, and we are doing our final, we're ready to go. So we'll get into a status here soon. All the systems will go through and say, yep, we're good to go, and we'll be ready.
And we're about 10 seconds away from that pull now, so let's listen in.
Okay.
LCAC.
L1 is 7 minutes.
Go AC. Confirmation from OS that we are in the correct RF patch configuration.
Roger. Status check to proceed with terminal count, Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
HASGAS.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GC cubed.
Go.
COM.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
AC is go.
Range coordinator.
Clear to proceed.
Launch director.
LC, you have permission to launch.
Proceeding with the count. ALC, verify T0 is set for 11:05 Zulu.
Verified.
OS, start list data capture.
And as you've heard, that poll is now complete. We are still within the hold, the T-minus 4 mark. But with the L clock, we're about 5 minutes, 40 seconds away from launch. And Alyssa, one last question for you. You have teams working at this launch site, and then you have teams in your company headquarters in Colorado. Mm-hmm. Can you tell me about how they're working together?
Yeah, definitely. So in Denver, like I said, those are our certified responsible engineers. So these are the experts in the system. They know everything down to the minute detail. So they're looking at the data as an overall system, but also digging into the details. At the launch site, we're in the countdown. So we're running the tests, we're sending commands, we're pressing buttons and doing those kinds of things, and working together with them as a full team, ULA team, to get it ready.
Sounds great, and thank you very much for being with us today for the launch, and we'll continue the countdown. Thank you
Thanks so much.
And with that, we'll continue keeping track of all the things that are happening as we lead toward liftoff. So let's get you up to speed. And first, welcome to those who are just joining us on social media. As you can see, we have a little bit of fog in the area today. You can see the Atlas V in its 401 configuration, and it's stacked on the launch site at Space Launch Complex 3, the West Coast launch site for the Atlas V. The Atlas V has many different configurations, but this 401 configuration means that we have a 4-meter payload fairing at the top. The 0 indicates there are no solid rocket motors for this mission, and the 1 indicates we have a single-engine Centaur upper stage. We are about 10 seconds away from coming out of the hold in our count. 4, 3, 2, 1. And we are at T-minus 4 minutes and counting. The United States Air Force has been monitoring weather for us, and as you can see, some fog on your screen, some visibility issues, but that's not a constraint for launch today, so we are green on the range in terms of weather. The Air Force range is also responsible for public safety during launches from here on the West Coast and has been coordinating with United Launch Alliance and the NASA teams, ensuring that launch area and the flight path are clear for the launch of the Atlas V rocket, and we have no collision avoidance cutouts or COLAs during the window today, but right now we're tracking to a 4:05 Pacific time launch. We're at T-minus 3 minutes, 20 seconds and counting. The Atlas boosters and Centaur liquid oxygen tanks are at flight levels. The NASA launch manager Tim Dunn has polled his launch team. The United Launch Alliance launch conductor Lou Mangieri briefed launch teams ahead of the terminal count.
3 minutes.
The launch conductor has also verified with the range controller that solar radiation is acceptable for launch.
Securing LO2 topping.
2 minutes, 50 seconds.
Atlas tanks to flight pressure. FDS internal.
We're at 2 minutes, 45 seconds to launch. The flight termination system on the Atlas V has just gone to internal. We're at just about T-minus 2 minutes and counting.
1 minute, 59 seconds.
Vehicle internal.
1:55.
Launch sequencer start.
1:50.
Securing Centaur LH2. Securing Centaur LO2.
1:40.
Launch enabled.
1:37.
FDS armed.
You're looking at a live shot of the encapsulated spacecraft on top of the rocket at Space Launch Complex 3.
LCU armed.
FCS
The launch azimuth or flight path tonight will be in a southeastern direction, hugging the coast of Southern California and Mexico.
1 minute, 10.
Vent valves locked.
We're about 1 minute, 5 seconds away from launch.
T-minus 1 minute.
Rock, report range status.
Rock, range is green.
And we have just heard confirmation that the range is green. After launch, we'll be hearing the voice of United Launch Alliance's Marty Malinowski. He'll provide a status of the flight of the Atlas V and NASA's InSight.
Minus 40 seconds.
We are listening in to the
Stable
final
at
minutes of
3.
the countdown.
Minus 28 seconds. 25.
Go status check.
Go Atlas.
Go Centaur. Go InSight.
We're at T-minus 15 seconds. 8, 7, 6, 5, 4, 3, 2, 0. And liftoff of the Atlas V, launching the first interplanetary mission from the West Coast, and NASA's InSight, the first outer space robotic explorer to study the interior of Mars.
Good. Check pressures and RPMs. Expect command for the RD-180 continues to look good at this point in the mission. Injector pressures, pump speeds, expected regions, moisture ratio controlling within expected parameters.
The RD-180 engine providing 860,000 pounds of thrust.
Vehicle body rates continue to look good. All booster systems look nominal at this point. Mach 1.
The rocket is now traveling faster than the speed of sound. Coming up, the rocket will enter max Q. This is the point where mechanical stress on the rocket reaches its peak because of the rocket's velocity and resistance created by Earth's atmosphere.
Coming up on the throttle down. Booster has throttled back, right on schedule. Signatures look good. Pump speeds, injector pressures continue to look right within band. Body rates controlling down the middle. Current altitude is 13 miles, downrange distance 7 miles, current velocity 1,965 miles per hour. Closed loop guidance has begun.
The first part of the flight was pre-programmed trajectory. Now the rocket is giving itself feedback on its flight path.
And Q alpha steering has begun. Body rates look good. Pump speeds, injector pressures, all within band. RCS pyro valve has been fired. System is now pressurizing flight level. Signatures look good. Current altitude is 30 miles, downrange distance 43 miles, current velocity 4,542 miles per hour.
You're looking at a live view from the Atlas V rocket. The RD-180 engine continues to burn.
Flight rates continue to look good. RD-180 is still performing well. Q alpha steering has been completed. Booster is now 1/4 of its liftoff weight. Currently flying at 4 G's acceleration. Boost phase cooldown has begun. Togo pyro valve has been fired. Moving the throttle to 5 G's.
We're 3 minutes 50 seconds into flight, and we're nearing booster engine cutoff, or BECO.
Back to 4.6 G's in preparation for BECO. Boost phase cooldown has completed. And we have BECO. Shutdown looks good.
And the RD-180 engine on the first stage of the Atlas V has shut down.
Stage separation. We have box and fuel pre-start. The GN2 purge firing of the RCS is underway. We have ignition and full thrust on the RL-10.
And the second stage engine, the RL-10, has ignited.
And we have indication of payload fairing jettison. Looks like a good step.
And the payload fairing that was encapsulating the InSight spacecraft has been jettisoned. The RL-10C engine, the second stage of the Centaur, continues to burn.
And
You're looking at live animation telemetry
look very good.
of the Centaur second stage on its flight path.
Our GN2 purge firings underway for thermal conditioning. Pump
As you can see to the bottom right of your screen, the flight path of the rocket.
Discharge all been banned for the SET-MR. And Centaur has gone to closed-loop PU control in a slightly fuel-rich mixture ratio correction. at the booster stage performance shows a very nominal booster.
For those of you that are just joining us, we had an on-time liftoff of the Atlas V rocket carrying NASA's InSight spacecraft, as well as two small CubeSats called Marco.
This burn is scheduled for 8 minutes and 56 seconds in length.
You are looking at a live shot of the Centaur second stage, the RL-10C engine providing thrust.
And the RCS line temperatures are warming to throttle temperatures as expected. Centaur now controlling just slightly fuel rich. Chamber pressures, LOX pump discharge, and fuel venturi all within band.
We are at 7 minutes, 15 seconds into the flight. InSight being taken to its trajectory. This will be the first of two burns of the second stage.
All Centaur systems look very good at this portion of the burn. Up on the roll to optimize to Tidris East.
And Tidris East is a tracking data relay satellite east.
And the RL-10 again continues to perform very well. Again, requesting a fuel-rich condition at this point in the burn. Chamber pressures, LOX pump discharge, and fuel venturi, all parameter. RCS line temperatures have nearly achieved bottle temperatures. Continue to see our thermal conditioning firings on the RCS. Tank pressures are stable. Body rates look good. Storage bottle levels are excellent.
We are just over 9 minutes into the flight of InSight.
And Centaur PU is now controlling at a nominal MR. In response, looks good.
You continue to see the flight path on the bottom right of your screen.
Centaur is currently flying at an altitude of 136 miles. Downrange distance is 1,261 miles. Current velocity 14,066 miles per hour.
This trajectory of the flight path will put the spacecraft and the Centaur in a park orbit before crossing the equator. It will go around the southern tip of South America. It will cross the southern edge of the Atlantic Ocean, come up over the Indian Ocean to the east of Africa, and cross over India.
Continues to control near nominal. RL-10 performance is as expected for the SETMR. Centaur is currently at an altitude of 131 miles. Downrange distance 1,461 miles. Current velocity 14,790 miles per hour.
We are 11 minutes into the flight of InSight. We have about 2 more minutes left in the first burn of the second stage RL-10 engine.
2 minutes to MECO. Centaur continues to look excellent at this point. Tank pressures, body rates, throttle pressures, all in family.
We're coming up on about 1 minute left in the burn of the RL-10 of the second stage.
1 minute remains in this first burn. Centaur PU controlling near nominal, RL-10 chamber pressure, LOX pump discharge, and fuel venturi, all appropriate for the ZMR. RCS line temperatures look good. Still seeing thermal conditioning firings.
And we are now 13 minutes into flight, very close to the second stage engine cutting off for the first time for one of 2 burns that it will take.
Centaur is now orbital. And we have MECO. Engine shutdown looks good. We have 4S settling motors on.
And you just heard confirmation from United Launch Alliance, Marty Malinowski, that we've had MECO. The second stage engine has cut off for the first time. The first burn of the second stage, RL-10, being complete, we now begin the long coast phase of this mission. The coast phase will end when the RL-10 engine ignites for the second time for over 5 minutes. Start of the second Centaur burn will begin over northeast Russia. The end of the second Centaur burn will be completed over the northern Pacific Ocean. After the end of the second burn, we'll coast for about 9 minutes so that the Goldstone Deep Space Network is in view for the separation events of the InSight spacecraft and the 2 Marco spacecraft that are traveling along. And that will happen over northeastern Pacific Ocean off the coast of Oregon. So with the long coast phase underway, we'll now go back to Stephanie Martin. Stephanie?
Thanks, Josh. For missions to other planets, the flight path has to be extremely precise to ensure the spacecraft lands or orbits in the correct direction. NASA's Amanda Griffin sat down with Callie Burke, the trajectory analyst for the InSight mission, to learn more about her work for today's mission.
So Callie, tell us a little bit about your role for InSight.
My role is the trajectory analyst here at the Launch Services Program. And so my job is to make sure that the rocket drops the spacecraft off at the right place and time and space. We have to consider these really complex journeys. You know, it's not just doing an equation once. The Jet Propulsion Lab, they do these things called pork chop plots. And so they consider many months they could launch and many months they could land on Mars. What's the weather conditions going to be like when they get there? We want to get communication during landing. So are the right satellites in place, or are we looking back at Earth at that time on the landing site? So there's all these considerations. And so we have 35 days we're looking at that we're launching, but only 1 day that we're going to land. We actually have a 2-hour window that we're able to do on each day. And so that's 25 opportunities. So there's 875 possible ones we analyzed.
Wow.
Yeah.
So to launch from California, what's different?
Here from Florida, we launch east safely, and we can go somewhat to the north and somewhat from the south. But from Vandenberg, if they launch east, they're flying over people, and so we don't want that. So we can launch to the southeast, as we are for InSight, and then we can continue going west and launch safely.
So we've heard a lot about planetary protection.
Mhm.
So what is that, and what is your team doing to try to help mitigate that at Mars?
So we have somebody here at NASA who's called the Planetary Protection Officer, which after a 9-year-old applied, I now jokingly, it's the Guardian of the Galaxy. That's why he said he'd be great. But the Planetary Protection Officer looks to both protect Earth from any microbes we bring from space, and then we also consider Mars and Europa, where we think there might be life. We want to protect them from bringing Earth bugs and basically creating life somewhere as opposed to finding it. The spacecraft, which we plan to have land on Mars, has been very specially clean. There's a whole team, but we don't do that with a rocket. We actually aim the trajectory a little bit away from Mars. We don't aim it straight at Mars, so that we don't pollute Mars.
Well, here's wishing you all nominal calls on launch day.
Thank you.
And a successful flight. Thanks, Callie.
We are 17 minutes into the flight of NASA's InSight spacecraft on its way to Mars. Our own Tori McClendon is in the Remote Launch Control Center with Scott Messer, the United Launch Alliance Program Manager for NASA missions, to get an update on today's launch. Tori?
Thank you. So, Scott, tell us how it's going so far.
Well, so far, Tori, things are really good. It's a very nominal count, and it's a beautiful, beautiful launch. A little foggy out there, but everything is going well and right on track.
All right. So, as we all know, United Launch Alliance is definitely no stranger to Mars missions. You've launched the Spirit and Opportunity and the Curiosity rovers. So, what is it like to now have sent InSight on its way to Mars?
Yeah, so you're right. We're very excited. We've actually launched every Mars mission since 1960, so we've done a lot of them. And but this one is super exciting, obviously, because we first launched from the west coast of a planetary mission onto Mars. So it's very exciting. And anytime we go to Mars, it's very exciting for us to give our customer a great ride and create mission success so that the InSight mission can do what it needs to do when it gets to Mars.
So, this has been a very busy year for you guys so far. Let's see, this is the 5th launch for United Launch Alliance so far in 2018. It's the 2nd NASA mission. All right, so what's up next for the team?
So, we've still got 2 more missions left to go. We've got the Parker Solar Probe mission going to the Sun, which launches in July, and then, of course, our last Delta II mission, which launches in September from out here in Vandenberg. So, a busy year for us with 4 missions. And very excited.
Oh, thank you very much. We're looking forward to the rest of the year and the rest of today. Thanks, Stephanie. Back to you.
Thanks, Tori. With many scientific missions, NASA partners with international space agencies to explore and discover new science. In fact, InSight has instruments from France's National Space Agency, called CNES, and the German Aerospace Center, known as DLR. NASA's Blair Allen has more.
Thanks so much, Stephanie. Yes, it's very exciting. We just witnessed an incredible launch, and we're here with 2 very important members of the space community, Jean-Yves and Pascal. Thanks for being on the show.
Thank you.
Thank you. So I'll start with you, Jean-Yves. Just thinking about the significance of InSight and the partnership, tell us a little bit about what it means for the French Space Agency to launch and see a launch of the InSight mission.
In fact, as you know, we have a very strong scientific community in France, which is totally devoted to Mars. And this is why we are on a number of Mars missions. And for us, InSight is perhaps not the ultimate, but a very, very important mission, because we are going to beat the heart of Mars with the seismometer that we put on board of InSight.
Yeah, and obviously that instrument is very important to the data that we'll get back. So we're very appreciative that you're participating as well.
Yes, and as you know, NASA is very selective in the choice which are made, and we are very proud to have been selected and to have a very strong partnership with NASA and JPL during the last 10 years. And I am sure that we will have a tremendous success once we will receive the data.
Absolutely, absolutely. And Pascal, how about for you and the German Space Agency? Tell us a little bit about what it means to see the significant mission start today.
Well, Germany is active in Mars exploration since more than 2 decades. Just you remember Mars Express and our high-resolution stereo camera scanning still the surface of Mars, and also contributing to many other U.S. missions to Mars. And we are very, very excited today that our instrument, the heat flow and surface properties packages, HB3, much easier to remember, is on board, is on the way to Mars, and will really reveal new insights about the interior of Mars.
Yeah, and this is really exciting here tonight because we have a scientist by profession and an engineer. Tell me, Pascal, a little bit about what it means for you as an astrophysicist. From that perspective, what it means for you to see InSight launch.
Well, I think we want to understand our neighbor planet, Mars. It had a very similar history in 4.5 billion years ago. We want to understand how the planet evolved and developed. It's important to understand how terrestrial planets evolve, and we learn from the experiments on InSight about that. And I think one of the important things is also that is really linked to, how life actually originated on Earth and eventually on Mars. And that is a very important aspect.
Absolutely. Thanks so much. And Jean-Yves, an engineering perspective, how does it feel for you as a former engineer to
Oh no, but launching to Mars is probably the ultimate launches. It's my third launch to Mars. I was in Baikonur in June 2003 for Mars Express. I was also in Baikonur in March 2016 for the first ExoMars and tonight. But the other launches finally are very simple. You have to launch. Here you have to launch, to cruise, to land, and to discover. And this is probably the ultimate mission for an engineer.
Well said, and thank you both for being on the show. We really appreciate it, and we're as excited as you guys are to see Mars InSight land and start getting inside the Martian surface. So back to you, Stephanie. It's very exciting. I hope that you can sense the excitement of myself and the international community here.
Thank you, Blair. We're so excited here in the studio as well. Now we want to test your knowledge for those of you tuned in online. We've got some InSight trivia. Do you know the answers? understanding the complex geological formation of Mars is an essential part of helping us discover how our own planet's future could unfold. Sue Smrecker, the Deputy Principal Investigator for InSight, is on set with Blair Allen from NASA Edge to talk about what's happening beneath the Martian surface. Blair?
Thanks so much, Stephanie. Sue, I got to tell you, before we get started about the interior of Mars, tell me, what was your experience during the launch?
It was fantastic. It was physical. I could feel the ground vibrating. The car alarms were going off. And I saw a little spark in the sky. But that's about it. But it was, it was just as emotional as if there was no fog in the way. So it's on its way, and it was thrilling.
Well, I'm so glad. I felt the same way. I didn't see it, obviously, but did feel it. And I tell you, it really is exciting, and now we're underway. And so let's talk a little bit about what's going to happen once InSight gets there, because the big objective is to get under the surface. So tell us a little bit about the science of getting underneath the surface of Mars.
Okay, so our main instrument is a seismometer, and so we use that to image the interior of the planet. Basically, anytime a quake goes off, it'll travel through the interior of Mars, it'll bounce off different density layers, and so it's like a sonogram. It'll bounce off when a change in the density of the planet. So we're going to measure the thickness of the crust. We're going to determine the seismic velocity of the mantle, which tells us about its temperature, and we're going to determine the size of the core. So all the structure.
Now, I'm wondering, the particular location that InSight, where it lands, was that chosen based on geological activity, or tell me a little bit about the region you're landing in?
So we're going to Elysium Planitia, and we are a competed mission, so we are trying to do things on a budget, and with the lander, it's a copy, if you will, of the Phoenix lander. So it already kind of had some engineering constraints. So that meant we could only land at a certain altitude on Mars. We go in. We don't want to crash. We don't want to, and we also are solar powered, so we need to be near the equator.
Right.
So that actually narrows it down a lot. And then the last thing that we wanted is someplace where we can burrow our mole for the heat flow under the ground. And happily, Mars provides a window into its subsurface via impact craters. So our landing site lead, Matt Gollenbeck, and many students mapped hundreds of impact craters and determined the depth at which there's a competent rock layer. So we found a place where we can get our mole down without worrying about that rock layer at depth.
Oh, well, I guess that's going to be pretty important for the mission, because it's going down pretty deep, I understand.
Yeah, up to 16 feet. So we think the first 30 feet or so should be okay in our region.
Oh, that's incredible. Now tell me a little bit about this mole. What kind of data are you actually getting with that sensitive instrument?
Yeah, so it hammers itself down and stops every about 1.5 feet. And it sends out a heat pulse, which tells us about the thermal conductivity of the soil. And then it keeps on hammering in steps down to about 16 feet. At that depth, we're away from temperature changes due to day-night changes, seasonal changes, and we're just getting the heat coming out of the planet. So we actually measure the thermal gradient with a string of temperature sensors that the mole pulls behind it. So with that thermal gradient and thermal conductivity, we get the heat coming out of the interior of the planet. So,
well, I tell you, it sounds like you've got the bases covered. Well, listen, thanks so much for being on the show, and good luck to you and the rest of the InSight team. Stephanie, we're learning a ton about what's going on with InSight. Thank you so much. Take care back in the studio, and keep giving us good information on the progress of the Atlas V and Centaur as they head to Mars.
Thank you so much. We're about 31 minutes into today's flight of NASA's InSight spacecraft on its way to Mars. Let's check back in with Joshua Finch in the Mission Director Center for an update on the flight.
Thank you, Stephanie. We had an on-time liftoff today at 4:05 Pacific. The Atlas V rocket roared to life with the InSight spacecraft. The InSight spacecraft is now, as you see on your screen through this animation, is traveling with the second stage. The second stage is on a coast phase. The RL-10 engine ignited for the first time and did its burn and is now shut off, and we're in a coast phase. As you can see from the bottom right of your screen, we're traveling just over the southern tip of South America, and this burn will be first burn was the first of two that we'll do. The second burn will put the spacecraft in the proper trajectory, and it will coast for about 9 minutes after this completion of that second stage burn, and then it will release the InSight spacecraft, and then a few moments later release the two Marco spacecraft at the bottom. But a beautiful liftoff in the pre-dawn sky at Vandenberg Air Force Base on the central coast of California. There was fog in the area, yet no constraint to launch. And speaking of launch, let's bring you some launch replays right now. And on your screen, you can see some animation of the second stage Centaur with the InSight spacecraft atop. And at the bottom of the Centaur, the two Marco spacecraft. We're in the long coast phase of our mission. And for right now, we've got some more Mars trivia for you, and we'll bring that to you right now. And you can see the InSight spacecraft atop the second stage, Centaur, of the Atlas V rocket, continuing on its flight path. We did have an on-time liftoff at 4:05 a.m. Pacific time. A nice launch in the pre-dawn sky at Vandenberg Air Force Base. We're still in our long coast phase for this mission before the second burn of the second stage engine. And while we're waiting, we'll now go back to Stephanie Martin for more. Stephanie?
Thanks, Josh. The twin Marco CubeSats will be the first small satellites to leave Earth's orbit. If the technology demonstration is successful, they hold a lot of promise for the scientific community. NASA's Chris Gerst is with Joel, the Marco lead mechanical engineer at NASA's Jet Propulsion Laboratory. Chris?
Hey, thanks, Stephanie. So, Joel, tell me about the launch.
Oh, it was fantastic. Even through the fog, you could feel the rocket lifting off of the pad and successfully clearing the tower and getting on its voyage. Really exciting time.
Now, take us to the next phases for Marco A and B.
Sure. So after about 90 minutes, the InSight spacecraft will deploy. 60 seconds after that, the first Marco spacecraft will also deploy off the second stage. The stage will roll 180 degrees, and then the second Marco will deploy.
Okay. So that's interesting because you're gonna let the InSight spacecraft go first.
Absolutely.
And then you guys are gonna be trailing.
Correct. Yeah, we all deploy off in slightly different directions, and then we fly as a loose cluster together over our 6-month trip to Mars.
Now, how do you think Marco A and B how are they gonna feel following InSight all the way to Mars?
Sure. Well, that's exactly our point. We are there to trail InSight, and we're eagerly awaiting our chance to fly over and catch up with them as they go through entry, descent, and landing. And we fly over and are able to relay their message back to the eagerly awaiting ears here on Earth.
Now, this is pretty cool because this is the first time we're taking a CubeSat that's traveling, out of low Earth orbit and going to another planet. Kind of take us through that process. I mean, what are some of the challenges of actually designing a CubeSat, constructing it and getting it ready for flight?
Absolutely. Space is hard. That's one of the difficulties with any type of satellite, and with the Marco CubeSats, there's nothing any different. Traditionally, CubeSats in low Earth orbit, you're close to home. You have a lot of opportunities to talk to your spacecraft. You're in an environment that repeats itself since you're orbiting the same body over and over.
Right.
As you get into deep space, you're in a much different environment. You're perpetually moving further and further away from the sun.
Right.
You get less and less power every day. Your environment is changing. Additionally, you are very far from everything that is familiar. There's no GPS. There's no Waze that can help you navigate.
That's a good point.
And the deep space network is your only way to phone home.
Okay.
One of the technologies that Marco is demonstrating on this mission is a brand new radio, very similar to what is flown on these larger spacecrafts, but a quarter of the size. This softball-sized radio allows us to communicate with the DSN radio in order to do things like navigate on our way to Mars and in order to communicate with the Deep Space Network and understand how our satellites are doing.
Now, once Marco, and we're all assuming it's going to do its job beautifully once it gets to Mars, and it's going to help out the InSight spacecraft. Once that is done, where did the Marco CubeSats go?
Sure. So Marco's primary mission is a technology demonstration to learn about these technologies. If we survive our 6-month voyage and learn all of about these technologies throughout that trip, we'll do entry, descent, and landing relay of InSight's information. After that, the 2 Marcos missions is complete. We'll finish relaying down data and engineering data to sort of see exactly how we performed when we're relaying InSight's data for entry, descent, and landing. And after that, we'll sail off into the sunset and sort of be in a heliocentric orbit for forever.
That's incredible. In fact, it's sort of you're laying the foundation for future CubeSats to be launched to other planets.
Absolutely. Yeah. It's a real honor and an exciting time to be involved in this investment into the future of small satellites and satellites in general. It's a really surreal experience to have worked on this over the past several years and to be here to see the launch and experience everything that all of these teams have put into their satellites together.
Now, a little bit of piece of trivia for the audience. I believe, correct me if I'm wrong, that Marco A and B have special names.
Absolutely. So Marco A and B were given the names by the team of Wally and Eva after the Disney characters from the movie Wall-E. And that actually has some basis in what Marco actually is. So the Marcos are demonstrating a cold gas propulsion system, which allows us to allows us to correct our trajectory on our trip to Mars. In the movie Wall-E, there's a scene where Wall-E jumps out of the space station and is flying around with a fire extinguisher. Our prop systems are filled with the same propellant that is in common fire extinguishers. So we, in essence, are Wall-E flying through space powered by our fire extinguishers.
How cool is that?
It's very cool.
Well, Joel, thank you so much for joining us today. I can't wait to see Marco in action and perform admirably and helping out the InSight spacecraft.
Thank you, Chris.
Stephanie, I don't know about you, but we got to come up with a special name for us because that's pretty cool having 2 CubeSats with special names. Back to you.
Thank you so much, Chris. Now, if you love that they are named after Wall-E, we've got some more InSight and Marco trivia for you coming up now. NASA Edge spoke to several InSight team members at NASA's Jet Propulsion Laboratory recently to expand upon NASA's goal to understand the interior of Mars.
We're here with Tom Hoffman, project manager for InSight. How you doing, Tom?
I'm doing great, Chris.
You getting pretty excited?
I'm very excited. We're getting really close. I can't wait to go.
Hey, tell us, what is InSight?
InSight is a geophysical lander that's going to go to Mars. It's going to land on Mars. It's going to deploy some geophysical instruments, specifically a seismometer and a heat flow and physical properties probe, and it's going to probe into the interior of Mars to understand what the makeup is. You can think of it kind of as a checkup for Mars.
This is a pretty cool mission because it's not like any other Mars mission that we've had to the surface before.
That's right. So in the past, we've only gone a few centimeters into the surface of Mars. Just basically scrape the surface. Right. In this mission, we're going to literally hammer in 5 meters, about 15 feet, into the regolith of Mars, so that we can put down a physical properties probe. What it's going to do, as it goes in, it's going to take measurements of the properties of the regolith, which is the soil, and at different intervals. And finally, when it gets down to its final resting spot, about that 5 meters, 15 feet down, it's going to be able to measure how much heat is coming out from the core to the surface. And the reason that matters is because with a hot core, we know that that's what basically keeps the whole planet alive, that hot core. So understanding how hot it still is and how much energy is still coming out from the core will really give us a good idea about how alive is Mars still today.
Bruce, it's absolutely fascinating to think of Mars as a living planet, but how do you do that scientifically?
Well, a planet is really, it's like a heat engine. You have the heat of the core that's trying to get out, and that's what's driving all the geology on the planet. And so what we need to measure are both the heat coming out, which is its energy balance, and sort of the motions that are going on. And we measure those with our 3 investigations.
How does that help you determine that information about the composition of the planet that you guys are looking at?
Well, the different parts of the planet have different masses, so the iron core is very dense and very heavy, and so what we'd like to know is how big that core is, and the size of the core is going to determine its effect on the wobble of the planet, so we can measure the size of the wobble, the speed of the wobble, and also the frequency, because it wobbles at different frequencies, and so all those things we can then sort of trace back to the size and the density and state of the core.
Do we have any indication so far that there's either a lot of seismic activity or rather enough seismic activity to get the data that you're looking for?
Well, we have some information. We have images from orbit that show us faults on the surface of the planet, and most of those faults are billions of years old, but we actually can see some that are younger, and by counting up the faults as a function of time, extrapolating it to the present, we can come up with an estimate of the Mars activity. We also have sort of bounding cases. We know that the Earth is going to be a lot more active than Mars. We know that the Moon is a much deader planet. We measured seismic activity on the Moon during the Apollo age, so we know that Mars should be more active than that, and the numbers that we estimate do come out between those two bounds, and so we have a good expectation that we'll see Mars quakes, but of course we won't really know until we get there.
So Dr. Ashatek, InSight has landed. Everybody's looking forward to start collecting science. But before you can start collecting science, you have to start deploying your instruments. Tell me a little bit about that.
So the first thing we'll do is we document our workspace using our camera on our arm. We'll take about roughly 56 images that have to be downlinked. It could take a few sols, a couple of sols to downlink them. Once those images arrive, they're downlinked, they'll be processed on the ground to build a digital elevation map of our workspace. The scientists and engineers are now going to work together very closely to select the two places they want to place the instruments. So once those sites have been selected, then we go on our merry ways to build sequences to actually pick these instruments and put them on the surface of Mars. The first one is the seismometer, and then once you're done placing the seismometer on the ground, this seismometer is very, very sensitive. If a butterfly sits on top of it and flaps its wings, it can detect it. So you can imagine if you have wind or any other disturbance going over the seismometer, you're going to get noise on your signal. So we have to put over it what we call a wind and thermal shield. Basically, it provides the seismometer almost a constant thermal environment and also protects it from the wind.
Now, when you put your heat probe down, once that starts drilling into the surface of Mars, that is, you're done with that, right? That cannot be moved.
Yes, that is correct. So what we do with the heat probe is we go through the same process. We work with the scientists, we select a site. Once we're done with that, we take our robotic arm, which is basically a fishing pole with a hook on it. You pick up the heat probe. It's got what we call a tether or a cable, because it's all mated to the lander. It gets its power and data and computing power from the lander. We pick it up, and as we move it, the tether is inside the heat probe, and we pull it out, and then we slowly bring it to the ground. It's very light, and we have to also be precise to place it at a position where there will not be any obstacles that would block what we call the mole from getting to the ground, from digging into the ground.
The seismometer is on the surface of Mars. The heat probe has dug down into the surface. What if you find out that the center of Mars is solid, that it isn't molten, it isn't hot? What does that tell you?
It tells us we've got some good science, right? Because whether it's molten, whether it's solid or liquid, it's the right answer. So that means we have the right answer, we have the better model for Mars. So it's a win-win.
At this time, we're about 52 minutes into the flight of the InSight spacecraft. And I understand that NASA's Chris has found Jim Green, chief scientist again, because he's full of energy and he just can't get enough of this.
Stephanie, you can't get enough of Jim Green. I got to tell you, I could listen to him for all day. Jim, tell me, I know there's a lot of fog, but we heard quite a bit out there.
Yeah. So I sort of hedged my bets, and I turned on, the iPhone app for sound. Okay, just like a SICE instrument looking for, Mars quakes. I was looking for Atlas quakes. and we heard it. We really heard it. Car alarms went off in the parking lot.
That's
oh
right.
My God, can you believe that?
I heard at least 2 or 3 car alarms going off.
I was worried it was mine, but I didn't care.
Now we had talked earlier about it's going into a polar orbit, so it's on its way now. We saw the track heading south, and so tell me how difficult it is to send a spacecraft to Mars.
Well, we've got to escape the gravity of the Earth. That requires a certain velocity. And so the ULA does a fabulous job, figuring out what the trajectories are, the sequences of the firing, and for InSight we have one more big event to give us that last push and then send us on our way to Mars.
Now this is really cool. We're gonna have spacecraft separation.
Yep.
InSight's gonna be heading out. Then we have the 2 Marco CubeSats are going to be deployed, following InSight to the planet, and then we have to wait.
Well, till November 26th. So that's only about 6 months. Right. Some of these windows that we have are actually longer. 10 months, 11 months.
Right.
And the reason why is, Mars is an elliptical orbit. And every 26 months there's an alignment where we can send a spacecraft to Mars. And so it's a matter of where that alignment occurs in Mars's elliptical orbit, because the Earth's orbit is far more circular.
And that's why we had a launch window between now and June 8th to make that.
Right.
Okay.
Right, indeed. Now, this is just like, as they say, hitting a golf ball in New York and, putting a hole-in-one out here in Vandenberg. And so we started Vandenberg, but the hole-in-one's going to be at Mars. So this is on a ballistic trajectory, which means it goes straight to the planet and then doesn't get into orbit, just goes right down to the surface.
That's pretty quick.
Yeah, it's unbelievable when you think about what we can do these days.
Now, we've been talking a little bit about these fun facts tonight. And so is there any cool Mars trivia you'd like to share with the audience?
Mars trivia?
Yeah.
Okay, sure. There's always Mars trivia. We use relays to communicate. And as the spacecraft comes down, it actually is going to be sending us information.
Okay.
It has 3 phases. The entry part, where we use a heat shield. Then we pop the chute after we slow it down to a few hundred miles per hour from, like 10,000 miles per hour as it hits the top of the atmosphere. And then after the chute gets it down to well below 100 miles an hour, then you have the retro rockets fire, and then it safely puts down. So we have to communicate that information, and it goes through the orbiters. And Marco, the 2 Marco spacecraft, indeed are those that are helping us out. And so the trivia question is, in the future, how will we be doing this for other missions?
That's a great question.
So if the Marco spacecraft work out for us, then that gives us a completely open opportunity for us to be able to use that same basic concept for other landed missions.
And not only that, but with the CubeSats, I mean, we talked to more students around this country who are getting involved in the CubeSats.
Yeah.
And there were also students involved with Marco A and B. I mean, it's incredible how you're seeing these young engineers, these future engineers, they're coming out of college and they're going up to their first interview and saying, I have a satellite in space.
Right. But, planetary CubeSats are really tough. And the reason why is the further you are away from the Earth, the harder it is to communicate. You need a bigger and bigger dish, okay? So if you wanted a CubeSat out at Saturn, you have to have a dish, that's 5 foot big, and that's far bigger than the CubeSat. How would you even deploy that, right?
That's right.
So, but at Mars, because we have this communication capability with the surface assets, we're now thinking about how we can use that to communicate with the CubeSats. So the CubeSats could be in orbit around Mars, communicate through the orbiters, and then send the data back. So the relay concept is really important, and Mars helps us with that one.
So one day when we have humans on the surface of Mars, we may have a fleet of CubeSats that's orbiting around the planet.
I'm sure we will. I'm sure we will. It provides us a framework that allows us to make a variety of very focused measurements and potentially take a lot of data, particularly if we can use a network aspect of it.
Jim, thank you for coming back for a second time. We really appreciate it. And Steffi, he is still filled with energy, even though the launch has occurred. He can go all day. Back to you, Stephanie.
Thank you so much. Now that you've heard a little bit of a teaser about those Marco's missions, why don't we take this opportunity to take a fun look at the Marco mission.
Communicating between Mars and Earth requires a complicated choreography, with everything in the right place at the right time. Sometimes hours can pass before information is relayed from one planet to the other. That's why when NASA's Mars InSight lander launches this year, the rocket will carry 2 tiny satellites on a technology test of their own. Meet Mars Cube 1, Marco, NASA's first CubeSat mission to deep space. These briefcase-sized satellites will travel separately from the InSight lander while they test out new miniaturized technologies. And if they make it to Mars, they could relay information back to Earth about InSight's descent and touchdown, and do it in mere minutes. Although this fast communication isn't crucial to the success of the InSight lander, this CubeSat test could change the way future spacecraft phone home.
The InSight spacecraft has a protective shell that shields the lander during its travels between Earth and Mars. It includes the mechanical units that safely maneuver the lander through the Martian atmosphere to a landing on Mars. NASA's Franklin Fitzgerald is with the spacecraft manager, Stuart Spath, who can tell us more about the major parts that make up the InSight spacecraft. Franklin?
Yes, thank you, Stephanie. Stu, as Stephanie was talking about, there are the major parts that make up the InSight spacecraft. Can you tell us a little bit about them?
Yeah, I'm glad to. There's about 3 major elements. The most notorious one, of course, is the lander, which touches down. But the second part is the aeroshell, the cocoon, the thermal cocoon that protects the lander as it enters into the atmosphere. And then the first part that's going to be in charge of getting us to the planet is the cruise stage. It operates us for the first 6.5 months.
Now, I know we're about 30 minutes off of separating from the second stage to go into the cruise stage. Tell us about that separation in the journey onto Mars.
Okay, so it's definitely going to be a nail-biting 30 minutes for us on the spacecraft team. As you said, we'll separate, and then we'll be on our own to get our own telemetry through the Deep Space Network, through our own spacecraft comm system. So once we get telemetry, we'll do a quick health assessment. We'll poll all the spacecraft subsystems, make sure everything's nominal, and then hopefully we're on our way to Mars.
What do you do for 6 months? What will InSight do for 6 months? What kind of operations will go on during that time period?
Well, the most important thing is the trajectory correction maneuvers. So about roughly 2 weeks after launch, we do our first TCM, as we call them, and that will actually bias us for a on-target landing at the planet. And then the 5 other TCMs will occur for the rest of the 6.5 months, and that will do precision pointing for the rest of the way.
Now, when it comes to entry, descent, and landing, we've seen airbags, we've seen sky cranes, we've seen descent engines. What factors go into what type of entry, descent, and landing a certain rover or lander will have?
Yeah, typically it depends on how big the actual flight system is, the lander. So in our case, InSight is based heavily on Phoenix, and Phoenix was based even 35 years before on Vikings. And so both the Viking landers and the Phoenix lander use the propulsive landing technique. So that's what we're using on InSight as well.
So once InSight touches down on Mars, what will be the next move?
All right, well, the first move is to let the dust settle. Then we'll deploy the 2 solar arrays. You see those in the wings that collect solar power for us. And then we'll start, over the next month or 2, start deploying the instruments.
And we look to get data from InSight within, you say, about a month?
Well, the science data will start coming in about a month. The actual engineering data to make sure we're healthy and so forth will come from MRO, Mars Reconnaissance Orbiter Link, a couple hours after touchdown. We also have tones directly from InSight that will give us a rough health and status. And then you know about the 2 Marco CubeSats that will also hopefully provide real-time telemetry for us.
Stu, thanks for coming on the show. I know you got to get back and get that telemetry data that you were talking about. We appreciate your time.
All right, my pleasure.
Stephanie, back to you.
Thank you so much. Not only will Marco be the first CubeSat to travel to another planet, it will also be the first CubeSat to transmit key atmospheric entry data for Mars InSight. Blair Allen with NASA Edge spoke with Marco project manager about the spacecraft's role.
We're here with Joel Krajewski, who's the project manager for Marco, an exciting CubeSat mission, the first CubeSat mission to Mars. Joel, I'm very curious. I love CubeSats. I've followed them for a while now. I can't imagine what goes into sending one to Mars. Tell us about how all this came to be.
So we have a mission that's going to Mars, that's going to land on Mars. And as we always do with our Mars missions, we try to have a communications relay while the lander is landing, going through its 7 minutes of terror through the atmosphere. So that a communications relay can send data back to Earth and we can see what's happening while it's happening. The InSight mission then has that with one orbiter called MRO. We saw an opportunity to send a couple of CubeSats with it that could, as a technology demonstration, see if they also could do the same job. It's kind of perfect in the sense that if our mission succeeds, we get data from our spacecraft and we've shown it works. If our mission doesn't quite succeed, the MRO is there to get the data also.
That's the redundancy then for you, actually. That's a primary for NASA, but
exactly.
Redundancy for your mission in a sense.
That allows us to take the risk of trying it out.
How are you going to get there? Are you going to ride on the spacecraft, or how does this work?
We are not going to ride on the spacecraft, actually. We are a whole separate spacecraft. The primary payload, in this case InSight, is up in the nose of the rocket. We're kind of used to seeing it. We don't get to be there. That's kind of the first-class cabin. We're in steerage, way at the bottom. So we're mounted outside of the third stage on the back side of the tank. It's called the aft bulkhead carrier, hanging just above the engine nozzle.
That's a nice way of saying it.
Yes, it is. Hanging just above the engine nozzle. So it's a rough ride. It's a shaky ride.
When will you deploy then?
About a minute after the InSight vehicle separates from the third stage. Third stage does a small 4-degree maneuver and then spits out one of the Marcos. And then it does a 180-degree roll and spits out the other Marco. And that way all three spacecraft, InSight, Marco A, Marco B, are all going in different directions so they don't bump into each other. And then they continue as a threesome with coordinated trajectory correction maneuvers so that on each maneuver they are kind of keeping in lockstep, close enough to be within a few thousand kilometers at Mars so that the relay can do its job.
It's now time for more InSight and Marco trivia. In addition to Marco's communication role, it is flying 3 new innovative technologies. NASA Edge's Franklin Fitzgerald spoke with Marco systems engineer Annie Marinin about these technologies that will be demonstrated.
So Annie, there are 3 new technologies that are going to be demonstrated on Marco. Tell me what they are.
So the 3 technologies that Marco will be demonstrating are a propellant system that uses a fire extinguisher fluid to navigate Marco around. There is a radio that is about the size of a softball that was designed at JPL to interface with the Deep Space Network. And there is an antenna It's a deployable antenna that's completely flat and it can fold up, but when it operates, it actually simulates a dish that gets a lot higher gain and allows us to send more data back to Earth.
Now, tell me a little bit about this propulsion system, because, you know, I'm thinking about the engines on a rocket when it takes off. That's not what's happening with Marco.
No, so the fluid inside the propellant tank is essentially what you would find in a fire extinguisher. So if you've seen the movie WALL-E, there's this scene where WALL-E flies around space using a fire extinguisher and it propels him all the way around.
Right.
That is essentially what Marco is doing. The thrusters are much tinier, but we actually nicknamed the spacecraft WALL-E and EVA because of that. So we have 8 total thrusters on the spacecraft, and we're using them for 2 things. One is to do what we call trajectory correction maneuvers, which are basically course corrections. So as Marco flies, we can control its trajectory fairly precisely. And there are thrusters that allow us to change the orientation of the Marco satellite while it's in space.
So basically, it's going to be kind of kicking out compressed air. Okay. Now, tell me about this radio. From what I understand, it's something new. It's built right here at JPL. Tell me a little bit more about that.
Yeah, so the group at JPL designed this antenna specifically to operate with the Deep Space Network, and Marco is going to be the first mission to fly this technology. So we've done a lot of compatibility testing with the Deep Space Network, and so we've shown that it's configured well and it will work. We just now need to fly it.
Okay, and then in third is the dish. This trifold antenna. Yeah,
it's called a passive phased array. And so one of the reasons why it's such a cool technology is when you launch a CubeSat, or any satellite in general, volume is a hot commodity. And so in a CubeSat especially, because the whole satellite has to fit into a box, the more box-like all of your components are, the better. And so this antenna folds into a volume about this high when it folds down, but it opens up. It's fairly large, and it simulates a much larger dish that would otherwise have to be curved and would be much harder to actually stow in that volume. So it could enable a lot of really cool communications technologies in the future.
Tell me about what your role will be with the mission as they fly to Mars.
I will be operating one of the Marco spacecraft, and for this mission, what that means is we'll be sitting on a console computer sending commands and receiving data from the spacecraft. So before every chance we get to talk to it, we get about 1 chance per day. We'll have a set list of commands and scripts that we want the satellite to execute. And so we'll upload those via the Deep Space Network, all remotely. And then as it's happening, we'll get that data back and see what the spacecraft is actually doing. And hopefully it'll be doing exactly what we told it to do.
We are an hour and 10 minutes into the flight of NASA's InSight spacecraft. At this time, let's do some more InSight and Marco trivia. We are about an hour and 12 minutes into the flight of NASA's InSight spacecraft on its way to Mars. Let's check in with NASA's Joshua Finch in the Mission Director Center for an update on the flight. Josh?
Thank you, Stephanie, very much. And for those of you just joining us, I'm in the Mission Director Center and I was paying attention to the launch countdown as we proceeded to a liftoff. And we did have an on-time liftoff at 4:05 Pacific time, and we had Mach 1. The vehicle reached that at 1 minute 18 seconds. It entered through an area of maximum dynamic pressure at 1 minute 27 seconds. The Atlas booster, powered by an RD-180 engine, had booster engine cutoff on time at 4:04. Followed shortly thereafter by Centaur separation. You're looking at that right now, the second stage with the InSight spacecraft stacked on top. We had the first burn of the second stage, which started about 4 minutes 20 seconds, and about 8 seconds later, the payload fairing, which was originally around the InSight spacecraft, was able to jettison. We completed our first burn, and we're now in a coast phase. The first burn of the Centaur lasted about 9 minutes. It inserted the combined upper stage and the spacecraft into a parking orbit. We're about 1 minute and 25 seconds away from the start of the second stage. The Centaur stack is coasting in its parking orbit until it reaches the proper position for start of the second burn of the Centaur second stage. The second burn will continue for about 5 minutes. The burn will end with main engine cutoff 2. And 9 minutes after that cutoff, we'll have the release of the InSight spacecraft, followed shortly thereafter with the deployment of the CubeSats Marco A and B. We're about 45 seconds away from main engine start 2, the RL-10C engine, powering the Centaur second stage. And 15 seconds away from main engine start 2.
And Centaur has begun its D-spin in preparation again for the S2 start. And we now have the MECO 2 plus 3 second open. Once again, the pre-flight predictions compared to actual show very good agreement and an excellent orbit achieved at MECO 2. Centaur has completed its turn to the spacecraft separation attitude. Centaur has begun to ramp from a 50% duty cycle to a 10% duty cycle. Signatures look good.
And from the Mission Director Center, we're in about a 9-minute coast phase before a spacecraft separation. And I'm joined right now by Bruce Bannard of NASA's Jet Propulsion Laboratory. And Bruce, can you tell me a little bit about the InSight mission and what your role is with this?
Well, I'm the principal investigator of the mission. I'm sort of in charge of the overall success, the scientific success of the mission, and so I have to kind of oversee all the different aspects of it with an eye towards making sure that it's going to do the science that that we propose to do, that we've basically been tasked by NASA to provide from this mission.
And what is the primary science objective for the InSight?
Well, the InSight is going to go to Mars to look beneath the surface and make the first map of the inside of Mars. We're going to delineate the thickness of the crust, the size of the core, the internal composition, and use those measurements to inform our models of planetary formation, planetary differentiation, and how the planets, the rocky planets, start out, and perhaps understand why some planets take a path that becomes a habitable planet like the Earth, and others take a path that becomes not habitable, like, say, Venus or Mars.
So we're going to learn about, by studying Mars, we can also learn about our own home planet.
That's exactly what we're trying to do. Yes.
And so, how long does it take for the spacecraft to get to the surface of Mars?
Well, we have about a 6.5-month cruise from here, and then once we get to Mars, when we enter the atmosphere of Mars, from there it takes about 6.5 minutes to get to the bottom of the atmosphere and land on the surface. So they're both 6.5, but there's a little bit difference in scale there.
And how long will InSight be doing its science on the surface of Mars?
Well, we plan to take about the first 2 or 3 months to get the instruments deployed. They're bolted to the top of the spacecraft, and we want to get them down on the ground. Our main instruments, a seismometer and a heat flow probe, and those both need to be on the ground in order to do their job. And so we have a whole process for in placing them on the ground and getting them ready to go. And once they're operating, we intend to make our measurements for about 1 Mars year, which is equivalent to 2 Earth years.
And can you tell me a little bit more about Marsquakes and maybe what you expect to learn from those?
Well, Marsquakes are just the Martian equivalent of earthquakes that we have on the Earth. And so when their forces build up in the crust, it causes the crust to break or crack. And when that snaps a little bit, it sends vibrations through the planet. And those on the Earth, especially those of us who live in California, we're very familiar with the shaking of the ground due to earthquakes. But what a lot of people don't realize is that the very sensitive instruments that we have, the seismometers that we have, are measuring earthquakes all the time. In California, not only do we measure the shakes that you might feel yourself, but we're measuring vibrations from quakes across the ocean, in Japan, in Europe, all over the world. And for scientists, those quakes they're like flashbulbs. They're lighting up the inside, in the sense that as those waves go through the planet, they're picking up information. They're affected by the material that they move through. And when they come back up and we measure them with our seismometers, we're able to analyze those waves and pull out that information that the waves have picked up along the path. And we can put together a 3D image, basically a 3D look at the inside of the planet. And we hope to do that same sort of thing at Mars. We've been doing it on the Earth for about 125 years now. And so on Mars, the inside of Mars is basically completely unknown. We know that it has an iron core. We know that it has a crust. We have some fuzzy idea from theoretical measurements or theoretical models about how big those things are, but they've never been measured. And InSight will actually measure those quantities for the very first time.
And so, being here on launch day and now having it launched, how do you feel at this point?
Right now, I feel a little bit drained because it's been so exciting all day long. It's the anticipation's been building up. We rolled the tower back from the spacecraft about 4 hours before launch, and suddenly, this beautiful rocket with InSight standing on top was exposed and lit up in the night sky. And that was quite a moment. Then we came back here, and the countdown comes down, and as you get closer and closer to the liftoff, there's more and more activity, more and more things are happening, and valves are closing, and tanks are pressurizing, and then you get down to zero. The thing goes off, and it's just so exciting, so intensely exciting. And now we're waiting to sort of finish our launch. We're not actually done with launch until we separate from the Centaur.
And separation coming up here very shortly.
Mm-hmm.
So we can hold for that.
Okay.
And we have indication of spacecraft separation.
That confirmation of spacecraft separation. Behind us in the room, a lot of excited people.
Now I have a short coast of approximately 34 seconds before we
You're looking at
separate
NASA Launch Manager
Marco
Tim
8.
Dunn.
This will be the first pair of CubeSats to go to deep space. They carry radio, high-gain antenna, and propulsion system with the goal to provide data relay to the Earth from the entry, descent, and landing phase of the InSight mission.
And just moments away from the first 2 CubeSats to deploy.
And we have the first Marco A spacecraft separation. Centaur is now spinning up. First half of the 180-degree turn. Centaur has completed the turn. Now in an attitude hold for spacecraft separation. And we have indication of Marco B being deployed.
And the second of 2 CubeSats has been deployed.
Centaur has begun the custom CCAM turn.
And a lot of handshaking going on in Atlas Launch Control as the InSight spacecraft is separated, along with the 2 Marco CubeSat also bound for Mars. Looking at a live view inside NASA's Jet Propulsion Laboratory.
And we now have the InSight separation open. And as all the other opens were, the actuals are very close to the pre-flight predictions and excellent orbit for the InSight spacecraft. With that, this completes the plus count commentary for the AB-78 InSight mission.
And attention all stations on countdown 2. The NASA administrator will be coming online shortly for a few comments for the launch team.
Sir, you're active on countdown 2.
Test, can you hear me?
Yes, Mr. Bridenstine. This is Tim Dunn with the InSight launch team at Vandenberg Air Force Base.
Well, hello, Jim. How are you?
I'm doing just fine, sir.
Well, am I live for the audience?
You are live, and we've got the entire launch team dialed in, listening to you on our countdown channel.
Oh, well, thank you so much, Jim. It's an honor to be able to talk to the whole team there. I want to start by thanking everybody who's worked on this for such a long period of time. I know this isn't something that you put together on a Saturday morning, but this has been years of work by a whole host of people for a very long time, including JPL and, of course, the launch crew at Vandenberg. I want to give a special thanks to ULA and congratulate them on 128 total successful launches in a row, 78 specifically for the Atlas V. I want to thank our international partners, Kness and DLR, for their hard work. This is a big day. We're going back to Mars. We did it from the West Coast, which is a first ever. We're going to look deep inside the interior of Mars. We're going to create a 3D image of what's going on inside of Mars, and of course the launch of our first CubeSats into deep space. This is an extraordinary mission with a whole host of firsts. It's important for our country. It's also important for the world, and it really establishes American leadership in a lot of ways. And I just wanted Jim to make sure everybody knew how grateful we are here at the headquarters, and especially me, since this was my first launch as the NASA administrator, that everything went so well, and congratulations to everybody involved. If it's okay, I'd also like to introduce the team there. To Thomas Zerbuchen, whom I know many of you know. He's the Associate Administrator of the Science Mission Directorate here in the headquarters, and I'll let him address you as well.
Well, thanks so much, Jim. I'm just really excited, just like you, enjoying a great morning and, crossing fingers and living through everything, all the animations, and of course also the explanations that we got from the team, both on camera and in the room. And I just wanted to thank the whole team. This is a team effort, like you just said, but also I wanted to tell you how much we're looking forward to doing the science and doing all this harvesting of everything we've been dreaming about in the last few years through all the sometimes agony putting these things together, like these space missions are. They're hard. That's why we do them, not because they're easy. And I just look forward to what we're going to learn from this amazing mission once we arrive on the other side of this journey. Thanks, Jim.
That is awesome. Well, thank you, Thomas. And Jim, I appreciate you giving me the opportunity to address everybody there. And it's, again, congratulations on a very successful launch.
Well, thank you so much, sir, for taking time to speak to the team. It means a lot to us. If you were watching the video, you probably saw the level of excitement out here. We are thrilled to be part of a first-ever launch from the West Coast going interplanetary. And thank you and Mr. Zerbuchen for taking time to speak to us this morning.
Awesome. Congratulations. You guys have a great day.
We will.
And as you just heard, that was our new NASA administrator talking to the launch team after a successful acquisition of signal from the InSight spacecraft. Great to hear from our new administrator, and you can follow him on Twitter at Jim Bridenstine. Tonight's launch of the Atlas V with InSight happened at 4:05 a.m. Pacific time. The InSight spacecraft and the two Marco spacecraft were separated. It's been a great night here from the Mission Director Center at Vandenberg Air Force Base. And with that, we'll now go back to Stephanie Martin. Stephanie?
Thanks, Josh. It was a beautiful launch tonight, and I believe that we have a recap of tonight's launch with Josh and Blair from NASA Edge. Guys?
Hey, thanks, Stephanie. I tell you what, it's been a great day.
Yes, absolutely.
A great launch. It was great to hear from the NASA administrator, from the Associate Administrator for Science Mission Director, and from Tim Dunn, the launch director, on a job well done to the InSight team and to the Marco team.
Well, and of course, we've also heard a lot from the principal investigators, the deputy principal investigator.
That's right.
Very exciting stuff going on. And as you heard mentioned several times, a lot of enthusiasm. I mean, look, people have been out here for hours into the wee hours of the early morning, and the enthusiasm is keeping everybody on point.
For us, Stephanie, it's been from the rollback of the mobile service platform, and then seeing the rocket out the pad. It was really cool. And then to kind of wait, those 3-4 hours to get excited for the launch.
Yeah, absolutely.
And to talk to 5-hour Jim Green, who is he's just full of energy and excitement, and it just really makes you get really excited about planetary science and learning more about Mars.
Yeah, no, it was cool. I mean, we didn't actually see the launch because of the fog, but you felt it.
Right.
It was palpable. It was tactile.
That's right, and so now we have spacecraft separation. Marco, InSight, it's on its way to Mars, and now we just have to wait till November 26th.
That's right, and of course Marco will be right there with them to get data from the ground.
Can't wait.
It'll be
Stephanie,
exciting.
It's been a great day, a great launch, and we're looking forward to the landing of InSight. Back to you.
Keep the energy going.
Thank you both. Tori McClendon is standing by in the Remote Launch Control Center with a very excited launch director. Tori?
There we go.
Thank you, Stephanie. All right, Tim. So I know how excited you and your team has been for this long-awaited day. Tell us how it went today.
Wow. So we just had spacecraft separation. I mean, it's thrilling. We got a spacecraft on its way to Mars. It's been an incredible day, night, morning. It's been a long evening for us. Been up for a long time.
Yes, we
but it was actually an incredibly smooth countdown. Weather here on the Central California coast, I know, except for the fog, it was incredible. Apologize for the visibility, the low vis of the viewers, but I hear it put on quite a show for sound.
Apparently it did.
Yes, but so all the weather constraints were met. Even the visibility constraint that got a lot of discussion over the last couple of days. The range assets here at the 30th Space Wing at Vandenberg Air Force Base performed exceptionally well. No problems there. We woke the spacecraft up about 45 minutes before launch. It woke up on time, and it did not have one bit of problem from the spacecraft. And then the launch vehicle, the mighty Atlas, performed yet again. We had a little bit of discussion early in the countdown about a ground system valve. We worked through that, no problems. And then late in the count, we had a few alarms that we needed to spend a little bit of time, understood those. They were not actual real alarms about the rocket. So that took us right up to about L-6 minutes or so. And then from then on, it was smooth sailing down to T0, right on time at the opening of the window. The ULA launch team demonstrated once again what an incredible team they are, and the NASA team that came alongside ULA, I'm just a small part of that team and incredibly proud to work for the Launch Services Program team. And then certainly our customer from the Jet Propulsion Laboratory that actually did all of the hard, heavy lifting with the InSight spacecraft. Lockheed Martin built the spacecraft in Denver. JPL worked alongside them. So just on all sides, just an incredible team. And if you saw any of the video of us in the control room celebrating, it's what a relief to have a mission success, a spacecraft on its way, happy, healthy. We've acquired the first telemetry signals from InSight already, so we know it's doing well.
Great. Well, thank you so much for joining us. Stephanie, back to you.
Thank you both. This concludes our live launch coverage of the United Launch Alliance's Atlas V rocket with NASA's InSight and Marco spacecraft, which are heading to Mars. For more information, please visit www.nasa.gov/insight. I'm Stephanie Martin. From all of us here at Vandenberg Air Force Base, thank you for joining us.